in this set, the basic info states there are 5 cities between A and B, and these are P through T, and the 5 cities between B and C, and these are U through Y. And the second important thing, it is given that the distance between A and each of the towns A onward till B is indexed with respect to the distance between A, P, which means if the distance between AP is X, the distance between AQ has to be 1.5x, and the same goes for the distance between B and each of the towns B onward till C with respect to the distance between BU. It means if the distance between BU is Y, then the distance between BB has to be 1.75y. And it is also given that the cab charges, which is uniform irrespective of cabs, are partly fixed, which does not depend on the distance traveled, which means if a person travels between any pair of cities between A and B, including these two cities, he has to pay some fixed cost irrespective of the distance he travels, and partly variable, which is directly proportional to the distance traveled, which means a person has to pay a variable cost also, which is directly proportional to the distance that he or she travels, which means that fare comprises two charges, fixed and variable. And after having a look at table, it can be figured out that the fare that one has to pay for traveling between A and Q is 250, and that of between A and S 425. From this we can try to find out the variable and fixed cost between A and B, and similarly then for B and C. If F is the variable cost for traveling between any pair of cities between A and B, including these two also, is F, and Vx is the variable cost for traveling every x kilometer between any pair of cities between A and B, including these two. Then the cost of traveling from A to Q will be F plus Vx into 1.5, which is equal to 250. Similarly, the cost for traveling from A to S, which is F plus Vx plus into 3.25, which is 425. By solving these two equations, we can get value of x as rupees 100 and that of Vx as rupees 100. From here, we can see that if a person wants to travel from A to B, he has to pay a total of fixed cost, that is F, plus variable cost into 5, which is 100 plus 100 into 5, which means 600 rupees. Similarly, we can calculate the variable cost for traveling between any pair of cities between B and C, including these two cities, and which comes out as, in case F dash is fixed cost rupees 75 and variable is Vy for traveling every y kilometer comes as rupees 100. So if a person wants to travel from city B to C, then he has to pay fixed cost, which is 75 plus variable cost, which is 100 into 5. It comes out as rupees 575. Now comes to the question. The first question is asking what is the fare of traveling from A to C via B without visiting any city more than once? Simply, it will be the fare of traveling from A to B, which we have already calculated as 600, plus the fare of traveling from C to B, which is 575, which means the total fare for traveling from A to C via B will be rupees 1175, which is answer C. Now come to the next question. How many pairs of towns are equidistant from B? As we do not know the relation between X and Y, so it is not possible for us to find the pairs of cities that are equidistant from B. Hence, answer of this question is cannot be determined. Move to next question. If the distance between AP, which we have assumed as X, and that of between UV, which is as per our assumption has to be 0.75 of Y, it means X by Y is 0.75 upon 1, which is 3 by 4. As we know that the variable cost for traveling every x kilometer is 100, and that for every y kilometer along the route of B to C is also 100. So from here it can be noted that of the variable cost from A to B and to that of B to C has to be the reverse of this ratio, which comes out as 4 upon 3. Hence A is the correct answer. Move to next question. In this question, it is given that if the distance between R and S is 10 km less than the distance between V and W. Let's check what is the distance between R and S, which is 0.75 of X, and this is 10 km less than the distance between U and V, which is zero point 0.5 of Y. This is the first condition, and second thing is given that the distance between AP is 20 km. It means X is 20, and by putting value of X in this equation, we get Y as 50. So now we know the values of X and Y. So let's check options. Total distance from B to C is 250 km. Let's check it. Total distance between B to C is 5. Y which means 5 into 50, this is 250, which means first option is true. Let's come to second option. The variable fare per kilometer from A to B is higher than the variable fare per kilometer from B to C. It is obvious. For traveling every 20 kilometer, we need to pay rupees 100 or 100 as the variable fare per kilometer from A to B, and that is that is also 100 for traveling every 50 kilometer between B to C, which implies option B is also true. Now come to next option. The fare from R to B is more than the fare from B to W. Similarly, we can check this option also, and in this we get the fare from R to B is more than the fare from B to W, and this statement is also true. Now comes to the last statement. If a tourist who landed at C paid rupees 325, he must have started for C from W. So check whether that cost that cost comes out as rupees 325 or not. W to C is 2, distance between W to C is 2.75 via, which means 2.75 into 50. We know that cost of traveling for every 50 kilometer between B to C is rupees 100. So the variable cost of traveling for 137.5 kilometer will be 100 upon 50 into 137.5 plus the variable cost, which is 75. On computing, it is obvious that this quantity has to be 275 plus 75, which is 350. Hence option D is incorrect, so it has to be the answer. So that